So I'm going to unmute a couple of you guys to build a base. We need to build a base in big data, and what will help you with that is you can learn any other big data technologies, because when you approach any big data technologies, there are a lot of fundamentals each of them requires, and these two sessions will enable you to appreciate and understand and evaluate each of those technologies. So that's the purpose of this, because overall big data is very vast, and uh, it is not only about Hadoop. There are a lot of technologies which involves big data, and when you learn Hadoop, you just know one aspect of it. So when you go into the other technologies, you need to know how to learn that. So these two sessions will help you build that foundation so that you should be able to learn any of these technologies with ease. So that's the purpose of this session. So that's why we call it as the fundamentals of big data. So there are few things which you need to look at, and again I will start with one slide and then maybe we'll go with the whiteboard. So usually we talk about big data. So we need to understand what is big data first, and then we need to see how do we address the big data problem. So where does big data come from? And this is from Gartner. The whole idea is that enterprise has what is known as dark data. So that this is a term which Gartner has coined, and termed enterprises has dark data. So if you go to a typical company or an enterprise, they will have their RDBMS or a database where all the structured information is stored. So if they are having a web application or a CRM application or any other application, their database backend is going to be the RDBMS. They will store all their data in RDBMS. They will do their analysis, BI and everything on that RDBMS and on their structured data. But those companies also have lot of unstructured data. For example, they have their emails, they have call center logs, they have their customer emails which is coming in, there is customer phone calls which are coming in, there are the complaints which are there, the surveys which have been done, and so on. So there is so much of enterprise level data which is never used for large scale analysis, and that Gartner terms as dark data. So the basic concept around big data is that we are like looking at all types of data. Sorry, I think it's. So we are looking at all different types of data within the enterprise, and we are trying to able to extract intelligence out of it. So from an enterprise perspective, there are two things. One is structured information and all the other unstructured information which is not analyzed, and that becomes the dark data. Apart from that, there are partners, customers who are supplying lot of structured information. There are a lot of information in the public domain, like the weather data, the credit bureau reports, the census detail, the economic details, and so on. There is also social data which exists. Then there is most of the sensor data which exists within the enterprise. Now, what does big data really means? Big data really means that we are looking at all this data, correlating amongst themselves and trying to get intelligence from this data and trying to make a decision out of that data. So that's what companies are looking as big data today. So this is the perspective where enterprises are coming from. So they are looking at data from various sources. They want to find patterns amongst this data and trying to build insights from that data. So we will look at that, and let's go a little deeper to look at a typical use case which is happening in an enterprise, and we see how big data is going to help them. So what we are trying to understand is what is big data, and till now we saw that from a Gartner perspective it is more about correlating various data from different sources to derive insights. Okay, so this is what Gartner has called out, and this is one good way of defining big data. But let's take a simple example. Some of the examples where we have seen big data working. One of the company wants to find out why my customer is churning. My customer is churning, or why my customer is going away from me. Now, today in traditional world, they have a system like this. Traditional system was, there was data coming from their CRM systems, that is the customer relationship management things which they have built in. They have their products systems which they are selling, the product information, they have their transaction information which are there in your transactional database, like this is the transaction, or I could call it as the sales data. They have their customer information. These are all structured data. Okay. So today what they are doing? They are using all this data. They are bringing this data to a operational store. So they are bringing it together at one place, and you could call this as a data warehouse for now, and then they create data marts which is solving certain specific problems. So let's say this is a sales data mart which they create to understand how sales is doing. So they also create, let's say, a customer data mart or understanding customer analytics. So this is more about customer data, customer and customer focused analysis, and they are trying to understand where the customer is churning. So basically doing a geographical analysis of this. They are saying which customers are churning. They can also find out which product has the most iteration or the churn. So these are various answers they try to answer today. But their problem is not this. They want to understand why customer is churning. The problem is why customer is churning, and none of this will give you that, because these are all information about data which is more about transactional oriented or structured oriented data, and none of them give them the why part of it. They give you what part of the data, what happened. So this actually answers what happened. So where is the customer churn, which customer is there, which product is there, how is the sales increasing. Those are certain things which you can answer. But why customer churn, it's little difficult to answer here. So what should enterprise do? They should look at their dark data. That is what we are talking about. Enterprise has to look at the unstructured or dark data which exists within the enterprise. And this data includes, let's say, customer feedbacks. So let's say this is a text file which is available where customer is giving feedbacks. Then you are getting information from customer web logs. So basically customer interactions from the site. So you have websites where customer is interacting, and that is the website logs. Then we have data from their customer emails, because I'm just focusing on customer today, so that is the reason I'm just looking at very focused one. So customer emails, call center logs. So these are all dark data. One second, I think. Okay. Satish, you can dial into the audio conference, that will be better. So we have the customer emails and then we have the call centers data. Now you can start bringing this data also into the warehouse. But the problem with the warehouse is structured and this data is all unstructured. So this is all structured data and you have RDBMS kind of structure. So what you need is to bring all this unstructured data. You need a system or a platform which is able to process unstructured data. So you should be able to platform to process dark data, and that's where big data comes into play. So you bring all of this data into a platform, you start to extract intelligence out of it. So you do the processing and enrich the data and get some intelligence, and then this information you merge with your traditional data. Then you can answer why customer churned. For example, we could see from the customer feedback that the customer is not happy with the service. You could go back to the call center log and say that yeah, the customer has been repeatedly calling for the same issue. He has been blasting in the emails for want of attention. His interactions in the website log shows that he is always getting exceptions or errors in the interaction. So this customer is most likely to have frustration and is going to churn. Apart from that, you will also see that the sales is also reducing from that customer because the customer is already unhappy. So this is one way where you can identify why certain things happened. So why a customer churned could really be answered by bringing in the dark data. And that is where we are entering into the world where traditional data is not enough. We need to go beyond all the unstructured or other dark data which exist to analyze, process and create a view so that we understand what happened, why it happened, and then using all this historical data you can predict what will happen. So you are going to from what to why to what will happen. So basically coming to prediction. So this is where the whole industry is moving towards. They want to advance information on why certain things are happening the way it is, and the data is going to tell them why certain things are happening and not just what has happened to their business. And this is the special case for big data. So this is just one example which I took in to explain what does correlating various data from different sources to derive insights means. And in this case, we have correlated the dark data with the enterprise data to derive insights on why a customer churned, and we will be able to now, using historical analysis, find out how the prediction is going to work out. Okay. So I will pause here for some questions while I give Satish the phone number. So any questions, please ask now. And for all those who came late, I will just summarize what I covered till now. But if there are any questions, I see one question on the screen, but I'll answer that. Any other questions? Go ahead, please. No questions? So I've sent the dial-in code. Okay, this is only for dial-in for US. Okay. So welcome folks, those who came in late. So what we are looking at is what is big data from a business perspective, and what we said that from a slide perspective it was more about correlating data. Correlations and patterns from disparate linked data sources yields greatest insights and transformation opportunities. This is what Gardner says. So basically what big data comes from is there are a lot of data within the enterprise. So we only looked at this data right now. We also have public domain data, we have social data, sensor data and other data. So we have even not gone to this in this particular example. So you could see the possibility of how far this could go. This is just one small aspect of where we can, just using the dark data, we are able to predict why when a customer is going to churn, or we can also find out why a certain customer has churned. So these kind of insights we can get it by analyzing the data which exists within the enterprise but which has not been used till now because there was no platform to process large scale data which is unstructured and which is lying around within the enterprise. So this is all structured data. Any questions? Or is it clear? Okay,
it's Satish. I joined a little late. I might ask you to explain a little later. So is it okay?
Yeah, I'll just summarize. So what we were looking at is we just started with introduction to big data, and I was more going at the business perspective of big data, and we are saying that big data is all about correlating various data from different sources to derive insights. Now to give an example to that, we took a customer churn analysis example. We want to understand why customer is churning. So we looked at what is happening today in the enterprise. Today in the enterprise, the structured data is coming from CRM, product, sales and customer. What we do, we bring that data through the operational store into the data warehouse. Data warehouse is more of RDBMS kind of a story. So from there we process some data and create some equivalent data marts from where we run BI reports and analytical reports to create. But what that data could answer is where is the customer churned, which geography it has churned, which customers are churning, which product has the most churn and so on, or which product has the least sale and so on. It is only trying to answer what happened. But our requirement is to find out why customer is churned. For that, we said that you can tap into enterprise has lot of additional data which is within the enterprise. Nobody is looking at it, which are customer feedbacks, interactions logs, emails and call center. So the idea is if you could tap into these data, bring them to a platform which can process this large unstructured data, which happen to be a big data platform. If you process and enrich the data and push it and combine with the existing data, you will get some more insights, which is why customer churn, because the customer feedbacks are talking about it, the customer interactions are giving complaints about it, customer emails are talking about it, and call center is talking about it. All of these are talking about customers' unhappiness and the key reasons for unhappiness. So if you can able to extract that intelligence and marry with the sales information, you will be able to correlate to find out why a customer is churning. And if you can analyze this data historically, you will be able to predict why a customer is, when a customer is going to churn. So this is where we are moving our traditional BI cycle from what happened to why it happened and what will happen. And this is one big aspect of big data. So I hope this is clear, and I'm going to answer one question. How do companies know what kind of valuable insight is hidden inside big data? How to size the investment proportionally? Okay, so this is basically what he's saying is, how do I understand and convince the enterprise that they should not only look here but also start looking at here? So this is a little tricky question, because it is not that always the enterprise business is able to appreciate the value the additional data will be bringing in and the value the dark data can actually bring in. So the best opportunity which we have seen it working with our customers is trying to show them a small POC, taking some of this data and showing them, saying, okay, this is how you really show insights. So this is one approach which has worked out well. Now how do you size the opportunity? Once you get some feedbacks around what it is, you know that, let's say a customer is churning. What is the lifetime value of the customer? If a customer churns, the value of the customer is going to go away. So there are models which can predict what is the customer lifetime value based on his historical purchases and his historical interaction. So the best way to derive is identify his long-term value and then predict, saying that if you implement this, you will be able to prevent maybe some of those cases, and hence this is the dollar value you are going to save. And this is how you should approach. And I took an example of customer churn to give this example of how one should convince the customer to venture into a big data project. And this is the way. There are two approaches. One is you can demonstrate a POC, and that's pretty much what has worked out most of the time. Otherwise, you have to identify the customer long-term value, figure out that if I could identify the customer's churn maybe 10 days before or 50 days before, I could be able to get this much of value. Gokul, I hope that helps. Okay. So this is the two things which we are looking at. Now this is all from business perspective. We have defined big data from an enterprise business perspective. Now from a technology perspective, let's look at big data. What is big data from a technology perspective? Because all these terms which I used here was business, which you can go and sell it to any business. But let's say you want to go and sell this to a technology guy and saying big data is all about technology. How do I sell him a technology? So let's go there and do that. So let me create this. So you will be getting these diagrams, and you will also get some slides, and you will get the videos as well. So don't worry about all that. Whatever you need, you will get it. It's more about understanding here. So focus on understanding and then you will be all set. So now today we will look at a different perspective. What is big data from a technology perspective? So let's understand that. Before that, again I will ask if there is any questions. it's better you ask the question so that we can answer those right away. So that will keep the class interactive and we will be able to get going. Okay, so no questions still. I'm going to go ahead. So we are going to define what is big data from a technology perspective. So let's say we are saying that today we are using traditional technology to solve a problem. So this traditional technology includes what all? It includes maybe a RDBMS. We also have maybe MPP databases. We might also have mainframes. So these are certain things which we are using today to solve your data problem, which means you are taking the data. Oh shoot. Okay, so now it's fine. Okay. So we are looking at big data from a technology perspective, and I'm saying that there is big data. So data is there, and how is the data getting handled? Okay. So you are trying today, traditionally your data is being handled by RDBMS, MPP database and mainframe. Now, what are the challenges? One challenge is the volume of the data can grow up. And everybody understands volume. Volume is nothing but the size. Size of the data is growing up. Second thing is we are getting variety of data, where we are moving from unstructured to unstructured data. So this data is also coming in now. Then we are also getting data at lightning speed, like sensor data and so on, is high velocity data, real fast data. Now, whether these technologies can handle this? First of all, none of these guys are really a real-time kind of a technology most of the time. Mainframe does some kind of real-time, but beyond that, it's not really real-time at many of the times. Because as the volume increases and being able to show real results in real time, these technologies are not going to really stand. And then bring unstructured data to it, RDBMS will collapse, MPP will collapse, and pretty much mainframe is the only one which would survive. So what really says is that when volume, velocity and variety increases, the ability to handle data is a challenge. Ability to handle traditional data by traditional systems is a challenge. And that challenge or that problem is known as the big data problem. So the problem is where traditional systems are not able to handle either the volume, velocity or variety of the data, then that problem becomes big data problem. So the problem is defined as a big data problem when traditional systems are not able to handle this data. And what big data technologies are? Technologies just tries to solve this big data problem. And what are those technologies? There are three types of high level technologies. In fact, there are 6 of those, but we will start with the 3. So there are some real-time technologies, real-time processing, real-time stream processing technologies or event processing technologies. Then you have large-scale batch processing technology, and this is where Hadoop comes into play. And then once you have large-scale batch processing, then you have also having large scale databases. Because when you have some amount of semi-structured data, you need large scale databases. You need large scale batch processing system. You have large scale stream processing system. So these are the core technologies which comes in and tries to help you solve the big data problem. Now apart from that, there are additional technologies which like large scale machine learning or analytics. Then you have large scale visualization and distributed search as other technologies which tries to help you solve the big data problem. So these are the technologies which helps you solve the big data problem. And Hadoop actually falls in a large scale batch processing environment. So Hadoop is here. Real-time stream processing engine, you will see technologies like Storm, stream processing engine like InfoStreams and so on. Then large scale databases, you have NoSQL databases here and NewSQL databases, which is some of those are like MongoDB, Cassandra, HBase. Those are certain technologies which you can see. HBase, then you have DynamoDB and so on. When we go to the large scale machine learning analytics, you see Mahout, MLlib and R, SAS and so on. When you go to large scale visualization, this area is pretty new. It's not matured at all. You see D3 visualization and some specific technologies like Palantir and so on, providing technologies which are large scale visualization. When you come to distributed search, you see Elasticsearch, Solar and so on. So this is the landscape of what we are talking about big data. So these are the technologies which helps you solve the volume, velocity, variety problem. So when traditional systems are not able to handle it, and that technologies are known as big data technologies. So these are big data technologies. So from a technology view perspective, if somebody asks you what's big data, your answer should be like when traditional systems are not able to handle the data because of either its volume, velocity or variety, then that problem becomes a big data problem, and the technologies which helps to solve that problem becomes big data technologies. I hope this is clear. Any questions here? So what we covered till now are two aspects. One, we looked at big data from a business perspective. Then we look big data from a technology perspective. Again, these are mostly from a selling perspective to say why you need big data. You need this technology because these technologies cannot handle volume, velocity, variety of the data. And hence the problem is a big data problem and you need these technologies to solve it. So that's the technology view of it. While I take some questions from the screen to answer. Okay. So there are two questions there I see here. First question is, in your experience, have you seen any big data initiative being undertaken from IT terms without business drivers? Or is it always started as a business initiative and transformed into IT? No. The early adopters of big data were all IT terms, IT projects. Okay, all were IT projects. They were not driven by business. For example, let me give one of the biggest case studies which we always refer. This was one of a very large high-tech company. And their problem was they were having lot of structured data and the volume was increasing tremendously. And their sales is growing very, very fast. Every product launch, the volume is growing tremendously. They had an MPP database in the form of Teradata. So this was their technology. So the problem was, as volume increases, they had to buy lot more terabyte data boxes than when they calculated the cost of it, the cost was going very, very exponential. So to keep the volume process going under traditional technology, the cost was very high. I don't want to quote the number, but yeah, the number was pretty much in hundreds of $1,000,000. Okay. And that was the place where they said that if we move all the processing where CPU is consumed in the Teradata to a Hadoop environment, okay, so we move all this processing to a big data platform, then what will happen is this big data platform is mostly open source, runs on commodity hardware, and the cost is pretty 1/10 of the cost. So you get 1/10 of the cost of appliance. So within a year, the project, instead of bringing boxes, if you fund a project, this whole project cost and the whole thing would come out in less than a year of funding. So this was the business case the IT team put in place and drive this project to bring big data into action. So the idea was not that it is always coming from business. In fact, majority of the early starters start from this as the particular use case, where you are trying to address the volume velocity variety challenge and your technology is becoming a limiting factor either because of cost or because of capability or because of scalability. You move to an alternative technology to solve that problem, and that's one of the use cases. So I hope, Google, that makes sense to you. The second question it is there, if Hadoop is limited to large scale batch processing, then why is that all other technologies are kind of woven around Hadoop and HDFS? Okay. The reason being is, there are two big reasons to look for. The way, when you looked at around 5 years back, okay, when we looked at 5 years back, the adoption to go to an open source technology was absolute zero for an enterprise. Only the high-tech companies which are very, very startup would actually adopt a open source product. You can remember 5 years or 6 years back, if you propose to any IT architecture an open source technology, they'll throw you out of the door. Now, what happened is, Hadoop came into the picture and it became so powerful with its capability that people forgot the open source part of it and started adopting, especially when Cloudera came in and said, we will be the official support partner for it, because everybody was worried about support and hence never gone to open source. But when Cloudera came and said that, okay, I am going to be the support partner for it and I will own the responsibility, people started adopting Hadoop. And that's how Hadoop got ingrained into the enterprise. Now when Hadoop is ingrained into the enterprise, the natural choice for every other technology which was trying to solve this problem was to build on top of it. If you look at the latest entrant into the market, the Spark came in with a Mesos kind of an infrastructure and it was totally non-Hadoop. But in the last 2 years, they realized that Hadoop is the one which is running faster in the market where enterprises is already adopted. So it's easier to people to adopt that technology if I overlay on Hadoop. And that's one big reason why you see the entire set of technology stack revolving around Hadoop. I hope, Gokul, that makes sense to you. Okay. The second thing which you see there is one more question. Vamshi said that you mentioned about 6 types of technologies to solve big data. Can we take an example for each type of technology? Okay. We talked about large scale structured data processing, and that's what I showed you right now. With a big data platform using Hadoop, we solved a batch process. But we didn't give an example for a real-time processing. So he is looking for, do you really have an example for this? Do you really have an example for this? And so on. If I understand your question, Vamshi, I hope that's the question. Correct?
Suresh, can you hear me? This is Vamsi.
Yeah, I can hear you.
Okay, so what I'm trying to get is, how are these technologies depend on each other? Like, does it help one of the other technologies, or are they totally independent of each?
So, ideally speaking, there is only one common thread which runs across all of them. And that common thread is, they are all distributed technologies. When I say they are all distributed technologies, it means that all of these guys run on a distributed hardware. They are not monolithic hardware. In the sense, you have different servers connected together to solve the problem. Whether it is Hadoop, whether it's NoSQL, whether it's Storm, whether it's Palantir, whether it's Mahout, or whether it's any of this Elasticsearch. So that's one common thread which ties them all together. That to solve a larger problem, you need to have the technology moving towards a distributed processing kind of a world. So that's the first thing. The second perspective here is, once you get into the distributed processing problem, the challenges amongst all of these technologies are mostly similar from a fault tolerance perspective, from a reliability perspective, from a scalability perspective, from a performance perspective. All of them revolves around somewhat of a similar challenge. Okay. So there is a common thread with respect to all of them running. But from an applicability perspective, each one of them stands on its own. You can have just a large scale database being used for a highly scalable website. It has nothing to do with any backend processing. You have a very large scale website like Amazon running their database not on RDBMS but on a large scale NoSQL database. You can have a real-time trade processing platform which is nothing to do with analytics or anything on a real-time stream processing engine. Okay, so these are like use cases which are standalone use cases which has no correlation with each other. But there are many use cases where all of them has to work together to solve a business problem. For example, if we are looking at a real-time recommendation engine, okay, a real-time recommendation engine which we will cover in one of the use case later on, you need to have large-scale NoSQL DB to store the real-time data. You need a real-time processing engine to collect the real-time data. You need a large-scale batch processing engine to process historical data to derive patterns and move all this together to solve the real-time recommendation engine problem. Okay. So to answer the question, each of these technologies can be standalone used as a use case, and also there are use cases where they work together to solve a problem. but the common thread is distributed technologies. Okay, so both exist. So Vamshi, I hope that answers your question, or the question was different.
That's it, Sudesh. I think that's pretty much it.
Yeah.
Thanks.
Okay. So let's move to the other question which is on the chat window. There's one more question. And so is it possible that some of these technologies were working on structured data side by side along with unstructured data? Yes. If you are looking at Hadoop, we say Hadoop is for unstructured data processing, but it is not required. You can do your structured data processing inside Hadoop. Let's talk about stream processing engine. Stream processing engine can do structured data and unstructured data together at the same time. You have large scale databases. These databases can store both structured and unstructured data at the same time. So, when we are talking about big data technologies, these technologies are supposed to handle any kind of data. They should not be too limited or too constrained to a structured data or an unstructured data. And that's where the success of these technologies lies. That they are so versatile that they should be able to handle different aspects of the data. Yeah, obviously some are strength and weaknesses across the segment, but the overall goal is that they are able to address most of the kind of data compared to RDBMS, which only addresses structured data. I hope that's clear. Okay, so we are going to move on unless I see any other questions coming from any of you.
Sudesh, one more question.
Mm-hmm.
In the new world with big data, do traditional systems exist side by side, or are they marginalized, or what is the ratio in the emerging world?
Okay, so let's take this example which I quote about this high-tech guy. Okay, so they try to move all their data from Teradata to big data platform. But what was their system? They had brought the data into Teradata, and then they had some BI reports which were running out of it. Okay. Now, why is the cost going up? The cost was going up because we were processing all this information here. So we said, let's move the processing here. Now, if we try to move these reports also on top of it, the technology is not matured enough to handle that. Okay. Then, if we try to do this, this will become an overkill. So we said we will not do this. It doesn't make sense. Let's not do this. Instead, let's process this data and let's move the processed data back to Teradata and let the existing system continue. So, Teradata system which we have already brought can be used to serve the data and let the existing data continue that way, where the processing is now moved to the platform and the technology can coexist. And this is called the augmentation of technology, where you are not trying to obsolete any technology, you are just trying to use the power of the new technology to solve that problem while not eliminating or marginalizing the existing technologies. I hope that's clear.
Yep, thanks.
So from a holistic perspective, if you look at it, big data has two perspectives. You can sell big data to a business, you can sell big data to an IT. When you go to either of them, you have to use your right perspective to solve it. When we solve to the big technology perspective, it is all about large scale data processing, it's all about scalability, it's all about reliability, it's all about cost reduction, and it's all about how do you handle all variety different types of data at high speed. While when you go to the business side of it, they don't really care about all this. All they care about is business insights. how can you correlate different data and bring insights onto the table? That's what they care about. How do you identify patterns on the data to bring in insight? And that's precisely what they look for. So these are the two different sides of the same coin, which we call as big data. Depending upon who sees it, the perspective is going to be different. And this is where I wanted to stop the concept on big data. I hope this gives you a big perspective on why big data is not a hype, because it's a reality. If you don't adopt big data, you are going to perish, because volume is going to increase, variety data is already there, velocity also there, and if you are not able to tap into all this by adopting to the new technologies, you are going to perish, and it's only a matter of time. Similarly, from a business perspective, if you don't go back and understand your data and being correlate and do proactive insights on the data, your competitor is going to do it and you are pretty much getting out. So big data is not about a fancy technology. It is the survival for the business going forward. And hence, big data is an absolute must. There is no company which can live without this. And that's where you are seeing the traction at such a rapid pace. Everybody who understands it now understands it, saying that if I have to exist, I have to adopt and get some insight. It's not about whether I adopt Hadoop or anything. I need to think differently and I need to come at a different perspective. And that's pretty much what it is. Okay.
Sudeep, one question on Hadoop. So we're using Hadoop to solve the big data problem for enterprises, right?
Yes.
So are there any technologies that are using Hadoop to come up with some product, like, let's say, is it possible a database implementing Hadoop?
Yes.
Let's say MongoDB or Cassandra or HBase? Are there any other products like that which use Hadoop to come up with their product?
Yeah, HBase is based on HDFS, which is Hadoop. Cassandra has a file system called CFS, but it also embraces Hadoop. Okay. Now, apart from this, when we look at Hadoop, you will find the way Hadoop is evolving is that it is evolving itself as a data OS, data operating system going forward. Okay. So the Hadoop has a bigger role in the overall ecosystem as it goes to the next level. So today we are operating at silos of Hadoop. Tomorrow, when the technologies gets matured enough, every enterprise is going to talk Hadoop as a data OS for them, where they just bring the data into Hadoop and they are going to use all different types of real-time batch, every processing on top of it to process it. So that's where we are heading towards, and we will look at that use case when we go to Yarn and so on. But the way is, Hadoop is the underlying platform for a lot of these technologies. But it is not to say that Hadoop is mandatory. Hadoop is there, hence use it. If Hadoop is not there, you will still find a way to use it. Okay. So we are moving ahead. I see a few folks who have joined recently. So if there are any questions, do let me know. Kavita, you are there? Okay.
Yeah, so I have a quick question.
Yeah.
Once we process some of the big data thing, are we going to store that in a structured database, or how are we going to, preserve that and use in the future?
So this is one of the secret in big data. Okay. And that's very difficult for people to realize. So human brain comprehend structured data very well. So even though I tell unstructured data, structured data, everything, finally what human brain comprehend is a structured information. And hence the whole process of unstructured analysis finally culminate into structurizing that unstructured data dynamically into some perspective. And once you structurize the data, obviously you can use existing technologies in other place to put that together and analyze it further. So that's the whole secret behind it. Everybody says, yeah, we are processing unstructured data, unstructured data, unstructured data. But the end of it, if you ask them, what happened to that unstructured data? Yeah, it's became a structure. Now, what is the secret on how can you convert an unstructured data to a structured data? We will talk about that maybe subsequently in one of the sessions. The secrets of how do you take an unstructured data and convert it to a structure. But the essence of it is, every data finally will culminate into a structured information or at least a semi-structured information, and intelligence are only going to be driven from that, because nobody in the world can understand unstructured data by default. Make sense? I hope. So don't get worried about unstructured. We will cover unstructured, but the secret is only one: convert unstructured to structured at some point of time. Now Hadoop is only enabling you to do that, and that's it. Okay. So with all this, I think we move on to the next section of this today's discussion. We introduce big data. We introduce some of these technologies. We introduce some of the use cases as well. So again, we will go in more and more of these use cases. So what I want to do next is look at what is Hadoop. Let's look at what is Hadoop. People talk Hadoop, Hadoop, Hadoop and so on. But let's look at what is Hadoop. So when maybe 1-2 years back, when somebody used to ask me what is Hadoop, we used to say Hadoop has two parts, HDFS and MapRedis. And I was also very ignorant at that time to say that, okay, we were learning Hadoop and we were trying to master Hadoop without looking at the larger perspective in picture. And this is what we will say. Hadoop has two parts. One is known as HDFS, which is a distributed file system, and a distributed framework called MapReduce, distributed programming model called MapReduce, which helps you solve large-scale distributed process. That's what the perspective was 2 years back. But after that, the perspective has changed. Perspective has changed and said that Hadoop is a platform. Hadoop is a platform for distributed data processing. A platform for large-scale distributed data processing. And sometimes we will add the term large-scale distributed batch data processing. Okay. So this is what people call it now. But I still have a different thought to look at it. So then let's look at it from my eyes, where I see what is Hadoop. So to understand that perspective, you have to look at what is a machine. Let's take any machine together or any computer. It has three parts to it, ideally. A CPU, let's say it has 2 CPU and maybe a dual core or a quad core. So 4 cores and 2 CPU. Okay. Memory, yeah, it has around, let's say, 8 GB of RAM. Hard disk, Okay, it has around 250 GB or 500 GB of hard. Okay, and maybe it has a network which is around 1 Gbps. Okay, so this is the characteristic of a machine, and you might have a number of these machines. So when I want to make these machines work together, I want the characteristics of the machines to come together. For example, this machine has 500 GB hard disk. This has, let's say, another 1 TB hard disk, and so on. So let's say this machine has 1 TB hard disk. This machine has 2 TB hard disk, and maybe this machine has 1 TB hard disk. So essentially, when I have 4 of these machines, I have 2 plus 4 plus 4.5 TB of hard disk. What I essentially want is, I don't want to manage these machines individually. I want to view as if I have 4.5 terabyte of space. I want to view it as 4.5 terabyte of space, a distributed file system. I want to see it this way. I don't care if a machine goes down. I don't care where the file is stored. All I care is, if I give a file to this 4.5 terabyte system, it should store it somewhere. When I ask it back to give me the file, it should give me back that file. So this should be the get request of the file. This will be my put request of the file. I really don't want to manage these small machines. I want a platform which will look at it like this, from a file system perspective. I also want to harness the CPU and memory of all these machines together to get me a very powerful machine which has all the compute processing capacity together. For example, let's say all of them are identical from a core perspective. So it's a 8 core, 8 4 32 core machine. So I get a 32 core machine with 8 4 32, again 8 GB, 32 GB of RAM. So I get a distributed compute engine. I get a distributed compute engine of this capacity, on which I can say run this job, and it will run the job in any of these machines somehow or the other and give me the output. All I care about is running a job on the machine and getting an output of that machine. So what is Hadoop? Hadoop is just this. Hadoop is just enabling you to put machines together to create a distributed file system and a distributed compute engine. And that's what is Hadoop. So you need to answer Hadoop, and you need to view Hadoop this way. If you view Hadoop this way, then what you are saying is, if you add another 2 machines, my processing capacity is going to go up, my storage capacity is going to go up, and I can handle more volume of data and more processing of the data. And this is precisely Hadoop, which is a large scale distributed processing platform. I hope you get what I mean and what I view as Hadoop. Is this clear?
Hi, this is Hima. Can you hear me?
Yeah, I can hear you.
How did you get this 32 core machine?
I got like 2 into 8, 2 into 4, that is 8 core in one machine. So 8 core here, 8 core here, 8 core here. So if I put together all those core together and I get that compute together in some form, okay, that power is basically what I am looking at. Now, how does Hadoop enables that? We will talk about later. But what you need to know is Hadoop is just doing this. It is giving you a virtual view of the file system, and it is giving you a virtual view of a distributed compute engine at your disposal, so that you only operate at this layer and leave the rest to the technology. So from all practical purpose, your interaction is going to be at this layer, but the processing will happen at this layer. So what is Hadoop trying to do? Hadoop is trying to simplify distributed data processing, and that's what is Hadoop. It is trying to simplify distributed data processing and nothing else. And the popularity of Hadoop is purely because of its simplicity. That it is giving such a simple interface that you just put the file in, you run the process, and it just cranks it. Okay, Emma, I hope did that answer your question? Yeah, you're on mute anyway, so that's fine. Anybody else? Any questions?
Given your perspective that this is going to become data OS, do you see even traditional RDBMS kind of systems eventually getting onto this kind of architecture?
It is somewhat coming. Okay, so there are already attempts made. For example, yesterday was reading about one tool called Splice Machine. Okay, and what they are trying to do is they have taken a Derby database, taken the database engine out of it, put it on top of it Hadoop, and trying to guarantee ACID kind of RDBMS capability right out of Hadoop. Now, I'm not vouching for them to say that, yeah, they are the best technologies and they will solve all their problems. But what I'm trying to say is, the industry has realized that this platform has tremendous potential and there is lot more things you can do on this beyond SQL. And SQL is one of that aspect. So we can always support SQL over Hadoop, but it is much more beyond that. So I don't think that in the near future you would see a RDBMS sitting on top of Hadoop exactly the way we are talking about. But yes, people are already making that attempt. Okay. Any other questions? If any of this is not clear to any of you, it's better to ask the question, because if you ask the question, it will help you clarify a lot of things. So don't feel shy about asking a question. If you don't ask your question, you will not get it. If you don't get it, it will not. Okay, so there is a question. What will happen if a job processing fail? Hadoop is so simple that it will automatically handle job failures, it will handle machine failures, it will handle process task failures and everything. It is so resilient that it takes care of it automatically. You don't have to worry. You submit a job. Unless the job continuously fails multiple times, it will not really fail. It will make multiple retries to solve the problem. And I hope that helps you. So it is such a technology that it is too distributed, it is too simplified that you start loving this technology after a certain time. It is such a cool technology.
Sudesh, one question. So, sorry, go ahead.
No, go ahead. Sorry, no problem.
what I was about to ask is Hadoop only OS specific? Is it like, for example, is it only support Linux machines, or is it Windows or any other commodity hardware?
So there are two questions to it. One is it commodity hardware or no? Okay. Or what is the OS dependence? From an OS perspective, the production implementation of all Hadoop instances are on Linux. Even though Microsoft has made an attempt to put Hadoop on Windows Server 8, okay, and it was working out, I personally have not seen any production implementation of the same. Even though I have done multiple POCs on Microsoft Azure's for Hadoop and so on, HD Insight and so on, I have not seen a production implementation yet. Maybe that's because of my limitation, but all my production implementation has been on Linux. So that's the answer to that. Now, from a hardware perspective, I don't think there is too much of limitation, except to say that, yeah, maybe the Spark machines and other machines will not be supported. But you would definitely have an x86 architecture which is going to get supported on any commodity hardware. Okay. So there is no very...
Hello.
Yeah, go ahead.
Can we implement this Hadoop in small sizes? That is like one PC.
Now let's define a PC. Okay, PC has grown enormously. So these days, when I recently went to US and tried to see Best Buy, I hardly found a machine with a 4 GB out there. Everything was around 8 GB. Okay, so on an 8 GB single node machine, you can run 4 VMs and still run an excellent Hadoop on that. Maybe not for production use, but for your test and practice, definitely. Now, on a 4 GB machine, yes, if it is a Linux based 4 GB machine with maybe a dual core, you still can run it. Okay. So now, whether enterprise runs those? No, enterprise doesn't run it. But if you will have, let's say, if I had a dream of my own, I would have expected Microsoft to put a Hadoop engine in all the nodes of Windows, so that everybody can share their files, they can process it, and everything would have been so easy in life. Okay, but I don't think they are still getting there. Coming to the overall Hadoop base, it's always Linux. The production implementations are always high-end nodes, upward of 8 GB RAM to 16 GB RAM, I would say, upwards, onwards, and maybe going beyond 16. A quad core processor minimum with at least a 2 CPU, so that means 8 core per machine, and a hard disk of at least 2 hard disk of 2 TBs or 1 TB. So that's the usual specification for a node in a Hadoop cluster. Okay. So that's basically to give you a rough idea on how the hardware looks like. The second part of the question was, what are the limitations of Hadoop? Okay. And that's an excellent question to ask today, because I presented a very rosy picture to say it can bring up all the hard disks together, it can bring up all the CPUs together and able to process. So when we started with Hadoop, the first version of Hadoop had a limitation that it supported only MapReduce as your distributed compute engine. But as we move to Yarn, that limitation is addressed. Now no more distributed compute engine is just MapReduce. You can run Spark, you can run Storm, you can run any of the processing. So that's gone. The initial version of the Hadoop had one more limitation, that is, file once returned into it cannot be changed. The thing still exists that the files in Hadoop are immutable, but they added a feature called append. So you can append certain data to a file, but you cannot change any data into a file in Hadoop. And that limitation still exists. A file written in Hadoop is not changed. It is only deleted. If you want to change or update a file, you have to just do it once again. Now, if you say what are the other limitations? At a file system level, I would say Hadoop compromises lot of POSIX requirement, and hence it is not suited for dynamic workloads which are very fast changing. It's more suited for large data processing which are slowly changing. So that's the nature of Hadoop itself. From a processing perspective, I would say most of the processing limitations has been addressed by Yarn by saying distributed compute engine is no more mappeds. So that's how I summarize the limitations. So if I have to summarize the limitations, Hadoop is append only. You cannot update any file in Hadoop. It is more suited for large scale data processing. If you have very small data, maybe alternate approaches might be better. Third, it is looking at large scale data processing at a batch infrastructure. Mostly when Hadoop is looked at, it's looked at as a batch where data is stored. When data is really coming in, you don't need a distributed file system. You need it only to store the data. Processing has to be still done at the compute edge. I hope that gives you some idea on the limitations of Hadoop. There's one more question, and there are two questions on the window. Production implementation means get and put commands on Linux storage of a file can be in Windows. No. Production implementation means live implementation in production which is running in a production environment. Okay. Production implementation means that where there is no more development or test, it is all live and people are using it for their business. Now, when I say get and put here, these are get and put similar to Linux, but we are talking about Hadoop get and put. Okay, it is not a Linux get and put anymore because Linux is not here. Linux is here. Linux is at each of the individual machine level. Okay, so this get and put which you do here is different. So let's say if you do a Linux get and put, you are doing it here. But what we are doing at Hadoop is we are doing a get and put at the virtual file system. Okay. Now the last part of the question was, can the storage be on Windows? As you would see here, there is no separate storage. The storage is part of the machine itself, and we are attaching the storage directly to the machine. In a Hadoop infrastructure, the storage is directly attached to the machine. Okay. So it is not kept separately. I hope, Madhvi, that helps you with all your questions.
Yeah, thanks, Satish.
Gokul,
And
we have,
is there a limit, in terms of adding a machines or memory or CPU to the infrastructure using Hadoop?
okay, so there were two things which came in that. So that a system cannot be endlessly scalable, and that's a law of nature. So if you say a system can endlessly scale, then I would be fooling you. Okay, but when I say a system can scale to 4,000, who is that? Can you go on mute, please? Okay. Somewhere. Okay, I'm just trying to figure out who is that. Okay, I've muted almost everybody. Oh, somebody on the phone is making a mess. So who is on the phone? Davita, you are there on the phone? Somebody is on the phone still. Satish, you are muted. Okay. Because I don't see the person here at all. Just give me 1 second. Yeah, so we were talking about the machine's limitation, and we were talking about in the MRV1 world, or in the old version of Hadoop, we were talking about close to 1,000 node, which after which the job tracker and others used to crumble down. But with the yarn, I think we have even seen 4,000 plus nodes going through, and those are like very, very large implementation. So in a traditional enterprise, I don't think you will even reach the limits in the next coming years, because usually an enterprise will go around 100 to 200 nodes, and maybe 1,000 node to be max. And then if we are reaching a 1,000 node cluster, that means the enterprise is really using Hadoop to the fullest. So right now, most of the enterprises are in their beginning stage. So 100 to 1,000 nodes seems to be a reasonably sized node. But we have seen nodes with 4,000 nodes also going very reasonably okay. So we are not in that stage where we will definitely hit a limit. But yes, to say that, yeah, there will be a limit. It is not going to be endless. And when we look at the architecture, you can figure out under what stress is this limitation going to come. Okay. So any other questions?
So does the enterprise require?
Yeah, sorry, one at a time. Sorry, Gokul, you can go ahead.
Yeah, this is Satish. From the practical, from the planning point of view, for a practical session, how are we going to do that? Are we going to do the clustering, with our PC, or how are we going to do that?
We have cloud machines. We are going to launch machines on Amazon, okay, and we are going to cluster those machines right on Amazon, okay. In fact, you can tell me I want 10 nodes, I can create a 10 node cluster and show it to you. Usually we take a 2 node and we create a cluster, because the same process can be replicated for n nodes. You would get bored doing that 10 node cluster, okay. But if somebody has a real requirement, do let me know. I can show it any node, any number of nodes on Amazon. We are doing to do that. From a practice perspective, we are going to have a 2 node cluster on the cloud, which is available every time for you to practice. Okay. And